So we are now recording. Share the screen. All right, so we are recording, sharing the screen. Okay, so as I was saying, so in this class, 10% of your grade is the project. Two projects. One, each one is project A and B, basically. Each one is worth 5% of your grade. So usually the one that you're free to do kind of whatever you want to do within the Linux space is usually like a configuration. So a lot of students just end up doing like configuring an email server and showing how that works or something like that, right? So something along those lines. Some of them do security things. So the key thing is you have to use Linux, configuration, that kind of thing. But I also like to assign project A, which is basically what everyone has to do. You can do this in groups of 2 if you want, or you can do this individually, okay? So it's entirely up to you. It's a configuration, okay, of a, an application, and not just configuring it, but showing that it works, okay? So basically it's not, it requires some theory, right? Some like concepts and things like that. So that's what I'm going to do this week, right? I'm going to go over all the details of it so that you understand, you can wrap your brain around it. And then I'll give you a problem example that you can do for it, okay? So the module is this one. So if you remember we've covered at this point account management. We also covered host-based firewalls. That was last week. We went over Netcat and several ideas. This week we are covering the topic of Hadoop. All right, so Hadoop is like a nice, interesting challenge for you guys to work on. Right, it's basically going to be a service, and I'll talk a lot about what this is basically. So some of our students, some of the students, like when they graduate, they go on to become like cloud people, right? So they do a lot of cloud stuff, configuration in the cloud of services. And what you end up doing is if you're building things in the cloud, not everything is just configuring desktops, right? So you end up doing actual applications. So some of our students have gone to Google and basically they work on, multiple computers working together, right? Like cluster computing. All right, so that's basically what this topic is about. It's just a very 1-week introduction to this idea, and then hopefully it's something that you find interesting. Okay. Obviously, I assume at this point you guys have gone through all the labs, so Linux is comfortable for you. You've done some networking related things, okay, with Linux as well. So that's what you're going to be doing now with Hadoop. All right, so I will go over this idea today. So Hadoop is a tool used for processing large amounts of data in parallel. So parallel computing, if you will, right? And also there's this idea that, what if you have one computer, but that computer is not enough to process all your data? What do you do then? So then you have to start thinking about cluster computing, right? Does that make sense, guys? So effectively, that's what Hadoop allows you to do. It allows you to take 2-3 computers or 1,000 computers in theory, right? And make out of those one single supercomputer type of thing. Does that make sense? So I'll talk about these ideas today. I will go over, a lot the theory and how this works, what are the different approaches, and then basically you can start to understand the project. Also, I'm going to assign a problem that you need to solve with this solution. Okay. To give you an idea, basically, I think I have here, some of the information. So I'll talk about this. Basically, kind of to give you a big picture of it, you'll take 2 VMs at least, right? And you're going to create a cluster, right, with Hadoop. So that basically you're going to be able to process a job on both computers at the same time as if they were one single computer. Do you guys see that? Do you guys understand that? All right, so that's basically the idea. And we have to think of a problem. Not every problem can be parallelize, okay? So some problems can be, right? Like if I want to count the number of words in all the books, well, I can take one book, count the words there. I can take another book, count the words there, right? So you can do that in parallel, but not every problem can be processed in this fashion, okay? So this is kind of what I'm going to motivate today. So basically here, these are the PowerPoint slides. So I will go over this, okay? I will start talking about where this comes from, what it is, and, we'll go from there. So let me go to the whiteboard and we can start talking about this problem. All right, so just to give you some examples of this, you probably have heard of AI things in recent news, right? So a lot of those models cannot be trained on one single computer, right? They have to be trained in parallel. It requires, computers that have a motherboard that holds 8 GPUs, and that's still not enough, right? So then you have to distribute that out into multiple of those machines. So imagine 10 of those with 8 GPUs each. So how do you distribute that? Do you see that? Okay. So that's if you use GPUs. Now imagine that you're Amazon, and Amazon is in the business but many years ago, Amazon, sells products, right? So what do you have when you sell products? You have seasonality. So what does that mean? That sales in December are going to be really high, and sales in January, February are going to be very low. Why is that relevant to computing? Well, it's actually really relevant because when Amazon is assessing how many computers they need to have to meet all their shopping needs or all their clients, they can't look at sales in January. They have to look at sales in December, right? Because if they only had enough computers for January, February, what's going to happen in December? Basically, they're going to have a lot of people coming in that will not be able to get to the website, right? It just won't be able to provide the service. Do you guys see that? So they basically had to then buy a lot of what are called commodity servers, just regular, like desktops with some powerful CPUs, but still normal computers. And they had to have all these computers for sales in December. But then what do they do with those computers in January and February? Half of those are basically not being used. Do you guys see how that works? So this is where cloud computing actually came from, right? So if you're Amazon and you bought an additional 1,000 computers for December, what do you do with those computers in January, February, March? And so they had the bright idea of, let's create cloud computing, right? And let's rent out the computers, and that's kind of where this comes from. And then now they have all these computers, and they have problems that cannot be processed efficiently in one computer. So then what do? You start to take all these computers and cluster them. Does that make sense? So that's basically kind of the history of this, where it comes from, Amazon creating the cloud, and then everything is in the cloud nowadays, basically. And, that's, a lot of the cloud computers are going to be Linux computers. They're going to be Linux servers. Why? It's a free operating system, right? So, you don't want to, you just get it for free for your thousands of computers that then you're going to cluster, right? So that's what we're going to talk about. So, kind of where that comes from. So the product that the application or the framework is called Hadoop, but it's based on a theoretical framework called MapReduce, okay? So I will talk about that. And in particular, I will start with just distributed computing. What are like the basic principles of it, okay? So these are actually really important things. And we're going to focus just on the CPU scenario, given that you guys don't have, multiple computers with GPUs, right? The VMs don't have that, but we do have multiple, we can have 2 VMs, so that's effectively having 2 computers with, with multiple CPUs. All right, so let's go ahead and get started. So that kind of just motivates a little bit. So I'll go over some of the theory, where all this comes from. And then, as I said, we're going to see how Linux can be used in cluster computing and to solve these types of problems, okay? solving problems in parallel requires you to think a little bit differently, okay? So, like we're going to do some scripting with Python, but your Python scripts are not going to be like you would do it if you would just had one CPU. So you have to take that into account, that you have multiple CPUs, that you're doing things in parallel. So when you develop your functions, they have to reflect that, okay? All right, so let me grab my pen. Here it is. All right, so basically as I said, and this is part of your term project, basically. So this is Hadoop. Okay, I will give you also some best practices. Basically, you will have to config this. Not today, this is your term project. You will have a homework assignment this week, but it's something that we can do without Hadoop. So I'll show you how to solve the problem without Hadoop, and then you will have to solve the same problem or a better problem with Hadoop, okay? So you will need to configure this. The idea is that you would have, let's say, as many computers as you want in a cluster, okay? And they all pretty much do the same thing, okay? They all pretty much do the same thing, which is basically to solve a problem. So there's going to be data, right? A lot of imagine this massive amount of data, right? And this data needs to be broken up into chunks and distributed out to all the machines. All right, and then you're going to process a little bit of the data here and a little bit of the data here and a little bit of the data here. So that means you're processing the data in parallel. And then once the data has been processed, you need to aggregate, right? So, and get that into under control. So that's what clustering is, right? So basically, or distributed computing, one of the computers needs to be the master, right? And then the other computers need to be the worker computers, okay? So that one computer does need to keep track of things. So basically today I will talk about these ideas. So Hadoop initially they came up with this idea of MapReduce, which is, it's like a type of an algorithm, if you will, a very, very simple algorithm for distributed or parallel computing, okay? So we're gonna think about how that works. These same principles, I mean, these same ideas apply to both the CPU environment, when you're, basically multiple CPUs distributed, or the GPU environment, which is another way of doing parallel computing. But, our focus, of course, will be more on CPU. All right, so let's go ahead and move over here. So you guys know that a computer basically has, we need to talk about the resources that are available. So we're going to say this is a single node architecture, right? So the nodes are going to be the computers now. And basically, obviously, you're looking at CPU processing, the computing, and the memory, right? And the storage, okay? So these are elements that you need to think about, okay? But the question is, what if the data cannot fit all in the same computer, right? So if you had all the books in the world, right? Or if you had all the text in the internet, that's a lot of data. And it's definitely not going to fit on one computer. So then you have to basically divide the data and read it in batches into each computer. Okay, so the idea of a cluster architecture. Okay. Is that you're going to have, so remember, obviously, there's going to be like a switch or something. And so this is the switch. And then you're going to have multiple computers associated here. So you have one computer, another computer. So, it's networking principles apply, right? So you're building on top of the networking infrastructure. So really what needs to happen for you to have a cluster architecture is that you need to install software here, software here, software here, and the software needs to talk, right? So that they need to be able to talk to each other. And usually that's going to be done, through connections like a tunnel. So last week we saw Netcat. Really, you want to use something that's secure, so you'll make the connections via SSH. Do you see that? So that's really ultimately all that's happening is you have a piece of software, Hadoop over here, and you install it on every machine. And as you do the configuration, you're going to set up accounts on each machine, and you're going to establish SSH connections. You're going to enable the SSH connections, and then after that, all the machines can, through this software and through the SSH connections, are able to coordinate to process the data. That's really the key to everything, okay? But cluster computing, you can have a lot of computers. Just to give you a statistic, which is crazy, but it's true, Meta has committed to building the equivalent of a cluster computer that would have the equivalent, they say, of 650,000 GPUs. 650,000 GPUs in a cluster. That's crazy, right? They haven't built it yet, but this is what they have committed to. So as of 2024, right, I remember, when my numbers here are for 1,000 servers, right? And then now I know that something like ChatGPT was trained on 10,000 GPUs, right? A cluster of 10,000 GPUs. And Meta now has committed to 650, one single cluster of 650,000. I don't know how they're going to build it, honestly, but you can look into it and you might find that fun. All right, so definitely, this is why NVIDIA stock has, I don't know if you guys follow the stock market, but this is why NVIDIA stock has like exploded, right? They almost say it's a bubble because it's just, if you had invested early on in NVIDIA, you would have made a lot of money. All right, anyway, so let's think about this. So let's start with a few ideas, right? So I'm not even, we need to start somewhere. These are like the underlying principles that you should always think about when you're thinking about parallel computing, okay? It's not really like too technical things, but it's just some basic ideas that drive everything of your design, okay? So let's go ahead with some statistics, basically, just to kind of illustrate this. So you guys get that we are trying to put a lot of computers to work together. I've already established that before you had all those computers available because Amazon needed to have enough servers to meet sales in December. So that meant that they invested heavily. So they did have the computers. Google is the same, right? So they need to have enough servers for search and all that. So one statistic I have here is that in 2011, we're in class. Okay. Yeah. In 2011, it was estimated that Google had 1 million computers like this, and in all of their data farms, data centers, right? They had about 1 million, not 1 million together, but just 1 million computers that they had used to build several clusters, right? So they had about 1 million computers using this, but 1 million used as clusters, as several clusters. So why is this important? So this brings up several issues, right? So one of the issues is that, computers fail. That's just, it's gonna fail, right? That's your IT students, this, computers will fail. So here's the statistic. So this, putting computers in clusters gives us several issues. So let's say there are several issues with, and I'll just say distributed computing. Okay, so there are several issues. Number one, nodes fail. Okay, number two, there's a network bottleneck. We'll talk a little bit about that. Network bottleneck. And number three, these are actually the main ideas. programming for distributed systems is really hard, okay? So that's the third one. So let's call it distributed programming is hard. And I'll drill down into these ideas. Distributed programming is hard. Okay, so there are several issues with distributed computing. We want to achieve this, but we have to consider that nodes fail, there's a network bottleneck, and distributed programming is hard. Okay, so let's look at the first one. Number one, nodes fail, right? So nodes can fail. All right, so here's the statistic. Out of 1,000 servers in cluster, in a cluster configuration, you will have one failure per day. That's just a statistic, right? So, you can think of that. So this is in the notes, so you don't have to write this down, but out of 1,000 servers, one failure per day. All right, so when you're considering building a distributed application, you have to consider this. So if nodes fail, then the approach needs to deal with this issue in some way, right? The other challenge is the network bottleneck, right? So network bottleneck. Network bottleneck. So this is really important because you may have a really powerful computer with a very powerful CPU, a lot of RAM, a lot of this. And then you have another computer with a very powerful CPU, very powerful RAM, and so on. But if they are working together, they are working together through the network. Do you see that? And the network is slow. Okay? And so that's going to be your bottleneck, actually. So for instance, if you guys think of computers, what do you have in a computer that connects all the components in the motherboard? You have something called the bus, right? You remember that? The bus is really fast compared to the network. So when you're building a GPU machine, for instance, it makes a lot of sense to get a computer that has a very powerful motherboard with 8 slots for 8 GPUs all connected through the bus. Why? Because that is super fast compared to having 8 computers with each one having 1 GPU, but they're all connected through the network. Do you guys see that? So this is a challenge. So then when you're creating a solution for this, you have to consider this. Do you want to build an application that processes a little bit of the data in one computer and then sends it to the other computer, and that computer processes the data a little bit, and then you send it to the other computer, and so on? Or do you want to minimize that, right? So one of the objectives is probably to minimize the amount of data that needs to be transferred through the network. Do you see that? So, devise something like that, okay? So we'll talk about that in a sec. Just to give you another statistic, if the network is a bottleneck. So if the network bandwidth is about 1 gigabits per second, then moving 10 terabytes of data takes about 1 day. Right? So, it's going to slow you down considerably. All right. So you want to build a framework for distributed computing that minimizes the use of the network. So for instance, a nice thing would be move the data to the computer once and never again. Do you see what I'm saying? And then do the processing there and so on, versus move all the data to one computer, then move all that data to another computer, then another, you're using the network too much, and that's a bad thing. So therefore, you need architecture that does not move the data too much, okay? So that's another guiding principle of the framework. And then, as I said, the third one is that distributed programming, as you will see this week, is not easy, okay? So, and we're going to do something very simple, like just count things, and it's hard. So distributed programming is hard. So you're going to need a simple model that hides most of the complexity, right? So that's why we have MapReduce. MapReduce. We're going to talk about this idea. And this should hopefully, as I said, just give you some principles of how to approach cluster computing. Because you may have to, there's something called MPI, which is a way that you can actually take some computers, write your own code, and create a cluster, right? But if you were to implement something like that, I would recommend that you think about these principles. Don't move the data too much. Think of how you can write the code in a very simple way, and remember that things are going to fail. So basically, yeah, as I stated, the three problems: nodes can fail, network bottleneck, and distributed programming is hard. So how do we address these? We have MapReduce, which addresses all three of these challenges. Okay. So let's think now how MapReduce addresses the challenges of cluster computing. So how does MapReduce address the challenges of cluster computing? Okay, so number one, if nodes fail, the simple idea is you would want to store data redundantly. All right, so basically on multiple nodes for persistence and availability. Okay, so store data, so redundancy basically. Of data. So the framework that you build, or if you use Hadoop MapReduce, will take care of this for you, right? But you have to build something that is going to actually abstract this, because you don't want to do it. It would be too complex, right? So, but basically you need a framework that will do that. The second was that the network is a bottleneck. So basically the solution is move computation close to data to minimize data management. All right, so the idea is you're going to have multiple computers, right? So every computer you use here is like a normal CPU, RAM type of a computer, like the desktops, basically. So each one has a CPU. And if each computer has a CPU, then that means that each of these computers can do computation. Do you see that? So what you want to do is, if you have a whole bunch of data, right, you want to take pieces of the data, move it to the computer, and the computation will be done there, and that's it. Do you see that? So every computer gets this piece of data, computation should be done there, that's it. And hopefully you only move the data once, okay, and never again. And then after that, obviously, once the computation is finished, here and here, all of it needs to be sent maybe to a master or something that will aggregate all the information. Do you guys see that? That's key here. Okay, and this is the practice that everyone will follow, right? People don't want, you take the data and distribute it out to all the computers. Okay, Hadoop has something called the Hadoop file system, which is the distributed file system, which is something that you guys will have to configure. It doesn't actually exist. There's not going to be a physical, but it's going to be a virtual based on the computers that you have. So that's kind of the idea. So I'll talk a little bit about that. All right. So anyway, so the solution to that problem is move computation close to data to minimize data movement. And then you want to have a simple programming model. And that's what I'm going to show you, how we can use two functions, a mapping function and a reduction function, to be able to process our data. Okay. So over here. So what does Hadoop provide for this? So Hadoop is now, remember, an implementation in Java. I believe it's written in Java, and it implements basically MapReduce. Implements MapReduce. So this is what you guys are going to have to install, configure for at least 2 nodes. So you build a cluster, and then you're going to process a job on that cluster, okay? All right, so Hadoop provides for this something called a distributed file system, or HDFS. So the HDFS, which stands for the Hadoop Distributed File System, okay? This provides global file namespace. It'll provide redundancy and availability. So it actually, what's really nice about it is, let's say you have 4 computers, right? Imagine you have 4 computers, and you follow the instructions to configure them with Hadoop. So each one has Hadoop now. So you've created a cluster. This is your cluster, right? So then you're going to basically create this Hadoop file system. Virtually, it is literally like just one file system, right? But it's actually a little piece of this file system is here, and a little piece of it is here, and a little piece of this is here and here, but it's abstracted for you. So when you want to add the data, what do? Do you have to go to the individual machines to add the data? No. You just go to the Hadoop file system and put the data there. Do you see that? So you'll create this virtual file system that now exists. When you add your data to it, magically, it'll split it and send it to all the parts. And not only that, but it's going to create the redundancy. So it's actually going to take a little chunk and put it in computer 1 and a copy of that in computer 2. Do you see that? And it coordinates everything. And when you are uploading data to this file system, it's like when you update data to your desktop. You just put it there, but imagine that your desktop is now this virtual file system, and so it takes care of everything for you. So that's what's really nice about it. Effectively, it makes it seem like you only have one computer, but it's actually multiple computers. Does that make sense, guys? You guys will have to do this, okay? All right. Okay. So that's called the Hadoop HDFS. Reads are common in this HDFS, but you don't have that many updates to files or writes, right? So the idea is that you're not writing too much, right? But it reads a lot. So really, you only want to write once, and then you do multiple reads on the data. That's kind of it's optimized for that. So if you're writing a lot to this system, then you're not using it as you should. It's not optimized. All right, so let's take a little view of the distributed file system. Now, keep in mind, the commands are going to be like Linux commands, but they're going to be specific to Hadoop. So you will have to start the Hadoop application, and within the Hadoop application, you'll do something like ls, right? And then you'll be able to read in the Hadoop file system, for instance. All right, so let's talk a little bit about the terminology. So this is the distributed file system, okay? All right. So number 1 here, data is going to be kept in chunks spread across machines, okay? And Hadoop takes care of all of that such that you don't have to worry about it. So data kept in chunks is kept in chunks. And that's just the terminology they use, so it's like the technical term. All right, each chunk is replicated on different machines, right? So each chunk is going to be replicated on different machines. Sometimes the servers that make up a cluster can be called chunk servers. So you're going to have chunk server 1, chunk server 2, all the way to n, right? And because the data is replicated, you don't care if a machine goes down, right? There's going to be another one to take over. Now, I encourage you guys to build the biggest cluster that you can. I think in the past, students have done up to 4. So it just depends on how much RAM you have on your laptop or something like that. but definitely the minimum is 2, right? It has to be a cluster. I have a set of commands that I know how to run to know if the job is running on both machines and everything like that. So when you guys will need to do a demo of this project, and that's the question I always ask is, run this command and I'll see what's going on, okay? So, but it's, it's straightforward. Now, I will say you have, when you're configure, as you saw with bind, configuration is similar, right? So text files, accounts, access control, all of that, right? Just pay attention. Some recommendations. Whenever you configure something in Linux, my recommendation is don't use a distro that's almost about to be end of life, right? Don't do that. But also don't go with the latest. Some people want to go with the latest version or distribution. I also don't recommend that. Instead, I recommend to go with like a middle, between like almost obsolete and way too new. And the reason for that is the documentation that you will find. You don't want to be the first person to encounter a bug and not find any documentation on how to solve it. Does that make sense? So I'm not telling you at this point which Linux VM to use. I'm not saying to use seed, or I'm not saying to use the latest. I leave that to you to figure out as part of your skill. I'm also not providing a tutorial for this one, right? You need to solve it. But my recommendation is, because this is a term project, is that, if you're going to configure on Ubuntu 2004, make sure that that documentation you find is for Ubuntu 2004. Okay, that it has to match. If it doesn't match, believe me, one little thing will throw you off, because every time they change, right? This is how Linux works. Okay, so I provide in this module some links as reference. You can read through those, kind of use them as reference, but you probably won't be able to configure it with that information, okay? Because you'll probably be using, I think that's for 1804 anyway, and that's already at the end of its life. I think 2004 is getting close to that. So, there's a couple of things that you need to like solve. Does that make sense, guys, for the mini project? But that's, as I said, that's Linux. Imagine you're in some organization and they just want to try out Hadoop for whatever problem they have. They're going to tell you, hey, here's these 4 computers, build a cluster, right? So how do you do it? That's kind of the scenario here. So you'll have to do that. All right. So yeah, so that's kind of the idea. Any questions? Should be a fun project. And as I said, I'm going to give you a problem to solve, which I will demo actually from beginning to end, as it can be, why do we, so if I have very little data, right? If I have just like a few all the books that Shakespeare wrote, I can solve that with my laptop, right? Something like Hadoop is useful when you have like all the books in the world, right? Or in a library, when you actually need cluster computing. Okay, so I'll show how to how MapReduce works and everything on the terminal this week, and with a couple of books, and then you guys will do it on the Hadoop environment. All right, so let's take just a quick look of this idea of chunks, just to kind of wrap it up. So I'm going to create a new page here. So imagine you have a file, right? So you have a file. And this file is, we're just going to think of it as a buffer in memory. So then we can split it up, right? So it's going to be, chunk 0, chunk 1, chunk 2, chunk 3, ... until chunk n, right? So these are the chunks that we have. So if you have then these servers, right? Just to kind of, give you the idea, however many you have, you create the HDFS and you load this file as a whole into the HDFS. Okay, but basically what you do is you load the file and the programs, as one thing, and then Hadoop we'll split up the files and we'll replicate the code to all the machines, right? So the code obviously needs to be written in a specific way for this to work. So now here, imagine this is chunk server 1, chunk server 2, chunk server 3, all the way to chunk server n. So as I said, what you do is you replicate these. So basically, you're going to take this C0, and there's a copy of it here, but there's going to be a copy of it somewhere else. That's what the replication means. All right. So if that way, if one server goes down, you can always find, use another one. Then you would have, chunk C1, chunk C5, C2, and so on, right? So you'll have C1 over here and C5 over here, right? And you can actually control the replication, how many copies you want and all of that, but Hadoop has its own default values for this, okay? And remember that these chunk servers don't just store the data, and they also do the computation. So these are regular computers like your desktops. So computing, so I'll write this in the next page. I'll just say chunk servers also serve as compute servers, okay? But the beauty of it is that you don't have, Hadoop will handle the distribution and everything for you. So chunk servers also serve as compute servers. Okay. All right. So that's kind of some of the basic ideas of this. All right. So the distributed, we've talked about the network bottleneck, right? And we talked about how nodes fail. Okay. So now let's talk a little bit about the distributed programming, right? So what is this MapReduce? So I'll give you a basic pipeline of what it is. All right. It's actually it's called MapReduce because it's actually two actions. One is called the mapping action, and then the other one is called the reduction action. Okay, so let's do it here. So let's say distributed programming pipeline. All right. So the distributed programming pipeline using MapReduce, right? What you're going to have is something like this. You're going to have your data, and I'll do an example of this, obviously, this week. So the data will go through a mapping function first, and I'll describe what that means, right? But you need to map the data in a specific way so that it can be processed in parallel. That's basically the idea. Now, I'll give a very simple example of this, okay? It's something that you guys can do. Obviously, this could be, it's only limited by your creativity as long as you follow these basic principles. All right, so you're going to do the map part, and then this will result in some data. Then usually what you do is you sort the data, okay, so that you can process it efficiently. And then once it's sorted, you're going to go ahead and reduce it. Reduce the data. And then finally, you'll get the results that you're looking for. Okay, so this is the overall pipeline to implement MapReduce. Right. Okay, so the next thing we're gonna do, so we've talked a little bit about these ideas. So actually, a lot of this, is, you install Hadoop, you create the HDFS, you load your data, the data gets distributed. So now you need to do the computation. Okay, so this is what we're gonna look at now. We're gonna do a MapReduce example, right? So that how to process the data basically. The map and the reduce are going to be two functions. So these are going to be actually Python functions or scripts. We're going to write two separate scripts, and then we're going to use the pipeline kind of to redirect the outputs from one function to the other, right? So that's basically the idea. All right, so let's do a MapReduce example here. Okay. So imagine that you have a file, right? So you're going to have some file. You're going to start with that. So that's your data, right? So you have a file such as doc.txt. For the examples, I'm going to recommend that you guys just use books from the Gutenberg library, right? That library has a lot of books, so you can use as many as you want, basically, right? So you take that document and you need to map it into such a way that, will allow you to process the data in parallel, right? So this is kind of what we need to do. So let's start there. So the mapping function actually in its simplest form can be very easy, very short, but you just have to get used to this idea. So I'm going to just kind of give you like a pseudocode, of the function. So basically, you're going to scan the input file. This is the input file, right? In Linux, I can just do cat doc dot txt pipe, right? You guys know this, right? So I can just grab that file, cat doc. I can do cat doc1.txt space doc2txt, and so on. And I can send all of those books, right? Pipe them into something over here. So this is the start of it. Then we're going to have a mapping function. We can write this in Python. We're going to use the standard in and standard out so that, we had talked about this a little bit before. Now we're going to use it once again. So you scan the input file, one record at a time, okay? So one record or one line at a time, one record at a time. And this is what's really critical about this. You're going to need to extract something you care about from each record as key value pairs, okay? So that's going to be, basically it's like you're taking things out of the document and you're creating these packets, if you want to call them that. And you just send out those packets. Do you see what I'm saying? It's like you create these units and now these units can be sent as little packets or little, whatever you want to call them, to the next step to be processed, okay? And that's it. That's kind of the idea. So obviously we're going to do a very simple example of this. So you're going to extract something you care about. You care about. As key value pairs. Key value pairs. And this can become units. So the important thing here is the key is basically like what allows you to match things, and the value is actually the thing that you care about, right? So about that key. And then after that, that's the mapping, basically, right? That's the mapping. After that, you can sort things usually so that you can process things efficiently, and then you're going to do the reduction function. Okay, so reduction just basically means aggregate, summarize, filter, or transform. So like adding things together, tallying things up, averaging things up, all kinds of things like that. Okay, so let's look at an example here. So you create the key value pairs. So let's go, sorry. You create the key value pairs. So, you got your document, or it could be actually a whole bucket of documents, right? And you're going to create key 1 and a value for that key 1, and then you're going to have key 2 and its corresponding value. Then you might have another key 1. So notice now you have 2 of the same key with its own value, right? And then ... all the way to kn and its corresponding value. So this is the first thing that you do, right? So you create the keys, then you're going to sort these keys very likely. So that means literally that you would now have K1, K1, K2, all right? That's basically the process. And this is because, you need to process the data a little bit more efficiently. And when data is sorted, it allows for faster computation. All right, and then once you do the sorting, this maybe sort in this example, then we're going to reduce. Okay. Reduce. So that's the overall algorithm. So now let's do an example of this, just so that you guys kind of understand. I'm going to have a sentence here. Oh, here it is. All right. So let's do the example with a sentence. So this is actually what the task, so the task and an example. So a task, okay. The task will be to count the number of words in a book, for instance. Count, or count how many times you see words in a book, right? So that's basic, count words in a book. Okay, so that's the task, okay? This is a task that you can do in parallel, right? Because you could give, let's say you have 10 chapters and you have 10 computers, then you can give each chapter to a computer, have it count all the words there, just give the totals of that, and then aggregate that, right? So if you find in chapter 1, the word the appears 136 times, right? Then in chapter 2, the word the appears, 50 times. Then you get those two totals, and then in the end, you get the final total, which would be like 100 and more than 150. All right, so let's take a look at how this would be done with MapReduce. Okay, so I'm going to have the crew. Oh, this is the example, right? The crew of the space ship, the crew. This is just so to make the example simpler. I know it doesn't make sense, but All right, so that's the sentence, right? The crew of the spaceship, the crew, okay? So now the first step, this is the data. Now, this can be a sentence, this can be a book, this can be 10 books, this could be 100,000 books, right? The idea is that we're going to perform the same task and we want to do it in parallel, all right? So we would use Hadoop basically to help us to distribute out the files, to distribute out the code. But in essence, it's as if we were only doing it on one computer. Do you guys see that idea? It's like you still, I'm going to demo this as it, on my laptop, and it'll have a basic pipeline. Then when you guys do this in Hadoop, you will do pretty much the same thing. But the underlying is that it's going to be done in parallel on the nodes of the cluster, all right? Okay, so let's start with this. So we have the sentence. So then imagine that would be, let's call this data, right? So this is data. So our pipeline actually would be like this. So if we were looking at the terminal, we would do cat data pipe. Then we're going to have the mapper .py. Then we're going to pipe that into sort. If you remember, at some point in the semester, we looked at some of the commands like sort on the terminal that we could use. Then you're going to pipe that into reducer, okay? .py. And basically this at the end would give us the totals, the counts. So how many times do we see how many times do we see crew, how many times do we see of, right? And regardless of whether this is, a sentence, a book, multiple books, etc. Okay? Especially because we would be using Hadoop instead of just the basic command line. All right, so let's go over here and let's now convert that sentence into key value pairs. Okay, so I'm going to do, first thing is I'm going to map data. So I'm going to map it. So that means that we're going to create key value pairs. Okay, make sense? Any questions so far? All right, so the crew of the spaceship, the crew, right? So the first step is literally to grab each of those words, that's the key, right? So the word itself becomes the key, and then 1. Do you see that? Because we're going to count, we basically just say, okay, I just saw and that's 1, okay? Then I'm going to grab crew, and that's also going to be a 1. Then I'm going to do of, and that's going to be a 1. Then that's going to be a 1. Space, that's going to be a 1. Ship, that's going to be a 1. Again, going to be a 1. And crew, and that's going to be a 1. You see that? So this is mapping basically. Here I've created key value pairs. All right, the next step is, you guys see that? Does that make sense? All right, the next step is, that was the mapping. You see it's pretty straightforward, right? But the point is you have to think differently. You would never think to program like this, right? But this is when you're doing parallel programming, you have to shift how you think about things. Okay, so this is a guidance basically. All right, so now we're going to do the sorting part. Sort. As it turns out, it's actually very efficient to do sorting on the Linux command line because it's really fast. Okay, so you want to take advantage of it. So now what does sorting mean? It means that, all the thus should appear together in sequence. So we have the, right? So that then, I'm going to start a little higher because I ran out of room. So the 1, okay, so that's this one, then this one, 1, and then that one, the 1. You see that? Okay, then the next one is crew. So we would sort it. Crew 1. We have another crew down here. Okay. We have of 1. Then we have space. That's also a 1. And then finally, ship. 1. You see that? That's basically the process, as I said. We're using this technique of MapReduce. We map whatever we want into these key value pairs. Then we perform some operation like sorting. And then once everything is sorted, we're going to efficiently reduce it, right? So this will, by sorting things, we don't have to like look at, like a for loop that gets this the, and then goes down here and looks at another the, and then another the, and then starts over again and keeps doing that, right? So that would be too slow. Instead, by sorting them, we do the. When it changes, we know we've covered all the thes, and we move to the crews and so on. So that's the reducer. That's the sorting part. Now we do the reduction. So reduce. And basically reduce just means we do the count, right? So now it's easy to compute the total. So it's the is 3. Make sense? And then crew is going to be 2. Of is going to be 1. Space is going to be 1. And ship is going to be 1. And in a simple example, that's MapReduce. Okay? Obviously, this is like the most trivial example. You can do all kinds of things, but hopefully this gives you the basic idea of it. Now, the key thing is you are going to have to write. So I think I did that in here. So this one and this one are the 2 Python scripts. So you're going to build a Hadoop cluster. Let's say you had 1,000 nodes or whatever. You'll have a master, right? And in the master, you're going to create the HDFS, load the data. Boom, Hadoop magically takes over all the computers, hard disk space, right? It's going to create the chunks, distribute all the chunks, create the redundancy and everything, right? So every computer in that Hadoop cluster will be responsible for its data to do the count, whatever it got, right? So imagine that that's this data over here. Obviously, also in the master, you're going to have to give it the mapping, the mapper and reducer functions. Do you guys see that? So you give those 2 Python scripts, right? And you're going to say, this is the pipeline, and Hadoop takes care of distributing out that pipeline to all the other computers, right? And then once you run the job, basically the computation is on the data, is going to be performed on every node. And then the reduction of each node, right, was, imagine this is one node that gives you this, right? And then there's another node that gives you something like this. So then that needs to be sent through the network to be aggregated together to provide the final result. Make sense? So this part comes from one node. And then other nodes will have their own reduction, and that is all that needs to be moved through the network. So imagine this is like 1,000 books, right? That would be a lot compared to just this amount of data that comes out of it. Do you guys see that? That's basically the idea. Okay, so this is what you guys will do. I recommend that you do this example for your project. The key thing, though, is that you're going to need to configure Hadoop first to be able to do it. However, this week will demo how to do this just on the terminal. Okay, and we'll get some results. I'll help you to write the code too, by the way. I should say the following because this is true. Hadoop actually provides scripts. So you don't always have to write the scripts, the mapper and reducer functions. In fact, Hadoop will have its own, right? It'll have its own functions for various tasks, so you can just choose those as well. That's perfectly fine. But I would recommend that, you should see how you can add your own Python functions and have them run through, because you never know when you want to tweak something, right, to your own needs, basically. Any questions, guys? Does this make sense? Yeah. All right. Let's keep going then. So that now we're just going to drill down into the code. So I've given you the basic idea of this. So now we're going to start writing the code for the mapping function, the reduction function, and then we'll just basically run it. Okay. So more formally now, I'm going to describe this. This. Okay. And like I said, this is done over multiple. All right, so let's look at the pseudocode for the mapping function, okay? So I'm going to do this. So this is going to be the map function. This will be like the Python code, basically. So map function. All right, so basically define map. Okay. So we're going to say you're going to get something like the sentence. And then given the sentence, you can say for each word in sent. Okay. And given that, you're going to emit the key value pairs, which is going to be the word and the one. That's it. That's literally all the code that you have to write for the mapper function, right? So you receive the document, you have to iterate through it. This could be the whole document. So you can treat the whole document as a sentence, and then you just, every word, give it a 1. Do you guys see that? The key thing here is to understand the basic principle of creating these key value pairs. Because the beauty of this is now you can treat these almost as packets and redirect them to wherever you want for the processing. All right, so the reduction, that's the mapping function. Okay, so now let's take a look at the reduce function. So the basic idea this one's a little bit longer. All right, so I think it's better that we do this on the virtual machine, actually. It's gonna be too much code to write. All right, so I'm gonna start the virtual machine, okay? And we're gonna build basically the scenario. So let me share the screen. Okay. So let's start up the virtual machine here. Okay, and we're going to implement this example step by step, basically. I'm only going to need one VM for this. I'm just going to start 2004. Okay. So what we want to do is we want to write a simple MapReduce program that will mimic a word count, but we're going to be writing it in parallel so that these scripts can be used in a parallel environment, such as the Hadoop framework. We will use the Hadoop streaming API when you guys implement it with Hadoop. That's equivalent to using the standard in and standard out provided in Python and the terminal. So this will help us to pass the data between our map and our reduce function. Okay, so we'll need to write that in. Okay, so let's log in. All right. All right, so let's open up the terminal. Okay, do ls-l, cd desktop. Yeah, so the map code is pretty short, but actually the reduce code can be a little bit lengthy. So I didn't want to have to write that on the whiteboard. Okay, so let's go to ITS 372, spring 2024. There. Plus, no. All right, so I'm going to create a new folder here. I'm just going to call it MapReduce. Okay. Yeah. All right, so this is going to be the environment. So basically what we want to do is we would give it some data. So you would do cat and some file. I don't have a file here, so I'm just going to do echo. This is the pipeline. Remember the command pipeline that we talked about some weeks ago. So I'm going to say echo foo q labs foo bar q. Okay, so this is the input that I'm going to give to my mapper. Okay, so I'm going to do pipe, as you know, And then here is where I'm going to provide the mapper.py. So obviously I need to define this, right? So this is the idea. The Hadoop file system, basically, you would load this could be multiple books, etc., whatever it is. And then you need to provide what the mapper and the reducer are. But here, I'm kind of just taking this, piping it into mapper. And then, as I said, I'm going to use the standard in and standard out APIs, basically. Hadoop calls these the streaming APIs, which help us to pass data between our map and our reduce functions. All right. So this is going to be the pipeline. All right. So let's go ahead. I'm going to hit enter here. This is not going to work. So now I'm going to go ahead and create my mapper function .py. All right. So we're just going to start. This will just create the key value pairs, and we should be able to see these once we write this code correctly. All right. So since we're going to be running this as an executable type, we should add the shebang. So if you guys remember, remind me, do you guys remember what the shebang was for this? I think it was like bin, environment, Python, correct? You guys remember if it was this? No. All right, so I'm gonna just do a test here. I'm gonna do print hello. Okay, that's my mapper function, just an example, just to try out the pipeline. Control X, Y, ls-l. Try to make this executable, right? So that should be what? chmod plus X and mapper, correct? Mapper by ls-l. So it is now, I've changed the parameters from here, the access control to this one, right? So I'm going to run mapper just to try it out. Hello. Okay. Now I'm going to run it in the command pipeline. So echo foo, and it works. Do you guys see that? So I've completed this pipeline. Now I need to pass whatever is in this side, whether it's, because it could be book1.txt, book2.txt, and so on, right? So you can give it all the books that you want without having to do anything. But in this case, I'm just doing these examples. All right, so now let's go into the mapper function again. So I'm going to open up the Nano editor. I can comment this one out. And instead, I'm going to need the sys library so I can use standard in and standard out. All right, so this will allow me to get something from the pipe, basically. So I'm going to do import sys, okay? And then I'm going to say something like for line in, and now sys.standard in. Do you see that? So this allows me now to get the text that comes through the pipe, okay? In theory. All right, so now let's just do 1, 2, 3, 4. And I'm just going to do, for now, print line. Got it? Any questions? All right. So let's try it out. Hit clear. Run the pipeline. Did it work? It did, right? So I passed foo q labs foo bar q through the pipe to mapper. And now I need to create the key value pairs, okay? So go back to Nano. I'm gonna remove this. I'm just gonna comment it. All right, so remember that the key aspect here is we need the key value pairs. So I'm going to do line equal line dot strip. Okay. And I'm going to split it into the words. So I'm going to say words equal line dot split. Okay. And given that, I'm going to have a list of words. And now I'm going to create the key value pairs from this. So I can say for word in words, colon, 1, 2, 3, 4. Remember, the goal is to pass this out to the pipeline again, right? So we're going to use, you know, basically put it out into the command line so that another function or another script can grab that and process it, all right? That's the beauty of this. You know, we don't have to write code to save this to a file. That would be very inefficient, right? So we don't want to work like that. So now for word in words, we're going to create the key value pairs and we're going to make them tab delimited. It's just an example. So tab delimited. So instead of separating it by comma, we're going to separate it by tab, the tab key. All right, so now I'm going to do print. Theory, this should work. Print, and I use the format string here, S, tab, S, and then I'm going to see if I can pass, word, comma, 1. Remember this, the value was 1, because this is just a simple count, and the key was the actual word. So let's see if this works. So the idea should be correct. I'm just not sure if it'll work.
Can you magnify the text in the Python? I couldn't quite read all those characters.
Yes. More?
A little more.
Better. All right, so let's try this one. Okay. Control X. Okay. Open it again. All right. So the idea would be that we can create the key value pair. So let's go to the command pipeline again. All right, there we go. Do you see? So it did work because before we were getting a simple sentence. Now we are getting foo tab 1, foo tab 1, Q tab 1, labs tab 1, and so on. If this was a book, works. This was 1,000 books, works. You know what I mean? If this was 1 billion books, you're going to run out of memory, and that's why you need Hadoop. That's it. But the beauty of this is it works like this, and once you understand this, it'll work in the Hadoop environment if you can get it set up, and you can do the parallel computing. So you see it's kind of like an abstraction of how to do things, right? And basically, it gets you there. Any questions so far? All right, so now that we've done this part, so that seems to have worked. Let's, the next part would be the sorting part, right? So let's take a look at that one. All right, so you guys remember this, I'm pretty sure we did this exercise before. When we were looking at these, we did. There we go. So let's add the pipe again, and now we can do sort, okay? So we're gonna do sort. Clear. There we go. What do you think? Did it work? We sorted it, right? So now they've been sorted. So we've got bar, all the foos together, labs, and all the Qs together. This is what we want. And also, you know, this you cat one book, 100 books, 1,000 books, it'll work. All right. So this is map. We've completed the mapping. We've completed the sorting. What remains is to do the reduction. Right. So now we want to do the reduction part. And for that, we need to create the new function. So I'm going to go ahead, pipe again, and we're going to pipe it into reducer.py, which is the other function that you need to provide once you have the key value pairs to do the aggregation that you want to do for your environment. So obviously we haven't created this function. We need to define it in a similar way. So I'm going to go ahead and do nano reducer.py. And once again, we need to add the shebang. It's going to be user, oops, bin environment Python and I'm just going to say here print hello reducer just to see that it works. Okay, so I'm going to do Control X, Y. We're going to change the permissions, so I'm going to do ls-l. So now chmod plus x reducer.py. Okay, ls-l. So it's an executable now. So the command pipeline should now work, as you can see. All right. So this is kind of the idea. So now let's go ahead and we need to continue to define the reducer function. Okay. So we can get rid of this now. And once again, we are going to use import sys. Okay. There we go. Import sys. This is a much more complex script, so we're going to finish this one on Thursday because it's a bit long. Currently, I'm just going to get the functionality of receiving the data. All right. But the code, how can I put this? This is not how you've written code probably before. So you just kind of have to think it needs the data to be sorted and then you do the count. All right. So, but let's just do the part of receiving the data. So I want to take, what I mean is I want to take my time on this on Thursday. All right. So I'm going to do for line in sys dot standard in, right? So once again, what this is doing is it's going to receive the data from the pipe in the command line and be able to process it. 1, 2, 3, 4. This assumes that it's receiving, let's say, this code assumes it receives key value pairs that have been sorted. Okay, so it needs for this to happen before it, so it can work correctly. All right, so now we're going to say for line in sys standard in, and we're going to print. We're going to print line basically. Okay, so let's go ahead and try this. So we should now be able to print those key value pairs again. Okay. So we invoke the command pipeline, and there it is. You guys see that? So we were able now to take the original data, pipe it into mapper, pipe it into sort, pipe it into reducer, and this can be done, you know, in a distributed environment, and that's basically the idea of MapReduce. Okay, on Thursday, I will finish up this script, so we'll kind of go over the whole thing, finish the exercise, and then what I usually do is I assign us a homework that you should kind of repeat this exercise with like 10 books from the Gutenberg library. That's very straightforward. Just download the books and run it. I'll show you like with one. And as I said, that's the problem that you need to, that at least this problem you should do for your project, okay? Does that make sense, guys? Are there any questions on the idea? All right, great. All right, so yeah, so we can stop here for today. If you have any questions, I'll stay for a few minutes to answer them, and then we will finish this up on Thursday. Please form your groups of two. Let me just end this.